Welcome to my 8th video for our 3rd chapter in the game design project. In this video we're going to actually get the enemy to attack us. Since we left off with a successful enemy that will move towards us with some decent AI behaviors, and so we got patrolling, then aggro ranges, and right now the enemy doesn't attack us. And so we want to start setting up some variables to get the blobs to strike us, and we'll start setting up the infrastructure for ranged attacks as well. So jumping into the enemy code, because this is going to be another coding heavy video. We've got a lot of sections, and let me introduce an idea that we can use to help clean up and organize some of our code. We can use headers to kind of sort these in the in the inspector window. So we go through, add a header for the basic stuff. I'm going to add a header for movement. I'm going to add a header for health. And I'm going to add one for combat. And one for AI. And so if we hit save on this, we've added these headers, and we go back, let it compile its script. What we'll see is when we go into one of the orange blobs, that our script here actually now has categories, bolded categories, to make it a little bit easier to navigate all of our different variables. If you actually jump out on Google, there's some tutorials about using drop-downs, so you can even simplify this further. So you just do a drop-down to select basic movement, health, combat, or AI, which is really neat, and probably a little bit beyond the scope of this video, but you can check that out if you want to try to sort that a little bit more. But we're in the process of expanding our attacking stuff. So let's go and add a few things into here. So we want to, I think we'll leave prefer ranged as like the first thing in our list. We'll do a public, I guess we need the melee attack range. So a public float for melee attack radius. And this is going to be the radius at which an enemy can hit us, and also the radius at which it will begin its attack at. And the area of effect for a point blank area of effect melee attack, meaning the blob's going to strike everything around it in a 0.8 units range. Keep in mind this is keep in mind the blob's collider size. Like if you actually have your melee attack radius smaller than your blob's collider, it'll never get in range of anything, because it will never, like if this was set to 0.1 and the blob's radius is 0.3, it'll never be in range to hit something. Alright, so we've got a melee attack radius. We're going to add a melee damage, so melee attack damage, so how much this monster will hurt for, and I'm going to go with 10. I don't even know if this needs a tooltip, but and then we need a knockback, melee attack knockback, and that will be depends on how much knockback we want to give the slime. Let's just go with like 4 so that it doesn't knock you back a whole bunch, but it's mildly annoying. Alright, so we've got all of our melee things here, and then as far as ranged will go, the settings will be set up on its projectile. So we're going to add public game object ranged projectile prefab, and this is going to be the ranged attack item that it spawns. So this could be null. That's kind of up to how we set up our enemies. And so if we decide to assign a prefab there, then it will be able to spawn that prefab whenever it needs to. Now let's set up some of the cooldown stuff. And we'll do it right here. Public float melee attack cooldown. So how long does the blob have to wait until it can attack again? So how long will it have to wait? And we can make a different one for ranged. So we can have a ranged attack cooldown. So you can have monsters have a a bigger wait time if they're a ranged attacker versus a melee attacker. A lot of variables. Wait time after the enemy makes a ranged attack. And the last thing we need is a protected float attack cooldown ticker. And this is the variable that counts down, keeps track of the monster's ability to attack again. So we did add a bunch of variables to the attacking section, but that's probably all we're going to need to add for a good while. So we're pretty fleshed out on our variables here. So inside of start, I do want to kind of make it so the monster can't attack right away. So we're going to set the attack cooldown ticker to the maximum of either its melee attack cooldown or its ranged attack cooldown. So that way the monster has to wait. So like if you spawn into a level and there's a monster close enough to shoot you, it doesn't shoot you before maybe you can understand what's happening. So it forces it to wait the longer of those two times before it's allowed to attack. Oh, and I think I'm missing my wonderful is attacking variable, now that I'm thinking about it. Protected float is attacking, and that's going to be set to false because it's going to start not attacking. Oh, not a float, it's a boolean. And so we'll set that to true when the monster is attacking, which will allow us to do things like apply the move modifier, like if it's performing a ranged attack, maybe it's not allowed to move. So it gives us some extra control over the logic of what's happening. And so start looks good. I'm going to save again. Inside of update, we are going to have to add one extra thing. We're going to have to add a cooldown for its attack. So I'm going to add that right under this update stun state. Let's go make another one called protected void update attack cooldowns. And inside of here, it's just going to be a really simple method. If attack cooldown ticker is greater than 0, then we're just going to subtract time from it. Attack cooldown ticker minus equal time.delta time. Now, I know I could have probably just slapped this inside of update, but I do like the uniformity of having all of these. So let's add it here. Update attack cooldowns. So we can also further organize some of this code a little bit. So I could take and let's grab this update AI method and let's go put it right here. It just jumped open and expanded. And a neat little feature we can do in C# is called a region. So if you do a # in a region, let's name this update behaviors. And then we can close it down here. We do hashtag end region. And what that'll let us do is we can actually minimize that entire region into this little block here. So we don't have the super massively overflowing amount of stuff on here. We can just pop this open if we need to take a look at the methods inside of there, and then we can kind of sort it from there. So we can even make a region here, region health and damage. We'll do end region. And so my check health and my hit method can now be kind of sorted there. And so overall, we're able to manage this file so much nicer. All right, and then we're probably gonna make another one for attacks, which is why I brought up this idea of these regions. Cool, so what we need to do now is start actually setting up some stuff for the monster to attack. So I'm going to do public, and I'm going to do a inheritance-based thing here called an abstract method. Now you might remember that an abstract method is a method that does not get defined inside of this class, and it must be defined inside of the children class. Even if the child class just doesn't do anything with an attack method, it's still forced to declare it, which basically means as a developer we're acknowledging and forcing every script that's going to inherit from enemy to have to implement attack differently. And I think that kind of makes sense. Maybe we'll change that down the road, but you'll see that this is giving me a red squiggle. And an abstract method, if I have at least one abstract method, then this class needs to become abstract. And the only difference is an abstract class is not allowed to be instantiated by itself, which means you can't have a monster that is an enemy, because enemy is too general. You need to have a monster that's an orange blob, or a monster that's a skeleton, or a monster that's a bat. You can't be an enemy because an enemy is too abstract of an idea to exist. It's not a concrete implementation of an enemy. And so that's what I'm doing here. This basically forces, if I hit save here, what's going to happen is orange blob now has an error until we implement the attack method. I'm going to move that. I don't want it up there. I want it actually down here. So I'm going to put it right there. So it forces us to have to implement an attack on the child class for it to be allowed to function. So that's what an abstract does. Very useful, obviously. Just adding a few comments here, because sometimes this does drive me nuts if I don't have the comments on them. So back to making our attack methods. So what is actually beneficial is we should define different types of attacks inside of enemy, because there's some commonality to different things. Like monsters will probably have a melee attack. How they use the melee attack may differ from monster to monster, but they should have a melee attack we can just reuse. They should have a ranged attack that we can reuse, because a ranged attack is pretty, it's spawn a projectile towards its target. It's pretty straightforward. And so let's kind of make some basic methods here. So we're going to make a protected method called capital PB AOE attack. That stands for point blank area of effect attack. Basically, it's a melee attack that hits a radius around the monster, but that's the term for these type of things, is a point-blank AoE attack. So all this really needs to do is scan for players and apply damage to them. So So we're going to do very much the same thing that we did for searching for a player. We're going to go make the collider 2D list of things, and that'll be equal to a physics 2D overlap circle all, searching from my transform.position and using a size of melee attack radius. So it's getting all of the colliders that are within the melee attack radius. Then we're going to loop through each of those colliders. So for each collider 2D, temporarily called item, inside of the list called things, if item.gameObject.compareTag is a player, so if it's a player, then hit the player. So let's first grab the player script. I feel like how it's called player and the variable is called script. Yeah. Anyway, so player script, item dot, I think I need to call gameObject dot get component player. So that's going to grab the player script and access it so we can apply the hit method to it. Let's see, calculate the direction of force. So vector 2, hit force. So kind of like what we did for player stuff is going to be the item.transform.position minus the monster's transform.position. So the vector from the player to the monster dot normalized to turn it into a unit vector of magnitude 1 multiplied by the melee attack knockback amount times 10, because that's kind of just been a multiplier that we've been working in here. And that looks good. Now, with this point blank AoE attack, we should then also make sure that we update the... And we have to kind of decide if we want this timer to happen if it hits anything, or just if this method goes off in general. So... So I think probably at the end of, if this method was called, we should apply attack cooldown ticker equals melee attack cooldown. So if the monster scanned for players to hit, it is now going to have to wait until it can attack again. Now, there's some thought of whether or not we should put an if statement around this to prevent this method from being run if the attack cooldown's not up. But that's kind of maybe up to the monster to be responsible for that. So we'll see. We need to now apply the knockback. And this is also where you could calculate like critical hit chances if you wanted to. So anyway, script.hit, passing it in melee attack damage, comma, hit force. And so that should bump the player back and deal the damage to the player. So that's our point blank area of effect attack. While we're here, let's also create a protected void for, you know what, actually let's also return it to a game object for a ranged attack. So this is going to spawn a projectile and then return a reference to that projectile that we just spawned. And that, I mean, maybe we need to track that projectile for whatever reason, so that's why we're going to return it. So this one I do want to add a protection on. So if, and actually let's just do game object projectile equals null. You'll see why I'm going to do that in a second. That's so that when I return the projectile, it returns null if it was instantiated or if not. So if range projectile prefab is not equal to null and target is not equal to null. So basically, the monster needs to actually have a prefab set, and it has to have a target it wants to shoot at. Because we're going to try to make it aim at the target. If there's no target, it would crash when it tries to figure out the angle to the target. And if there's no prefab, it would crash if we try to spawn a prefab. So it's not like, if we didn't set either of these, it's just not going to spawn a projectile. It protects us from any sort of accidents. So let's calculate the angle to the player. So the angle is going to equal math.f arctangent 2. Actually, let's go get our, there's a little bit more math here than I want to do in one line. So target dots position dot y minus transform dot position dot y. That's my delta y. Float delta x. Target dot position dot x minus transform dot position dot x. So in arctan, we're going to pass in delta y, comma delta x. And so that's going to calculate a angle towards the player. We calculate the vector to the player. We don't need to normalize it because arctan will handle that for us. And then we need to convert it into degrees. So we have to do math.f radians 2 degrees. And it'll multiply by a multiplier to convert this into degrees. I mean, again, I hope you appreciate all that time in pre-calculus and physics learning about all of these trig things. The game engine handles a lot of that for us, but unfortunately, we still have to do some ourselves. So then we're going to set projectile equal to the instantiate command of the ranged projectile prefab. It will be spawned at the transform dot position of the monster. And it will have a rotation of quaternion dot Euler. And we're going to rotate it on the z-axis. So it's going to be 0, 0, comma, angle. So that's going to rotate the projectile so it's facing the player. You may have to think about that based on your projectile. If it looks silly rotated, maybe you won't rotate it, and instead you'll just set a field on the projectile script that will keep it from that'll move in the angle that you want. So just kind of keep that in mind, that this is going to rotate it to face the player. You may not want it to do that. All right, and so if we called ranged attack, my attack cooldown ticker is going to be set to the ranged attack cooldown, and I want to return projectile. So it will return null if I didn't actually spawn a projectile, but otherwise it will return a reference to the projectile that I spawned, just in case the enemy that's actually spawning the projectile needs to reference it for some reason. Maybe it's got to change the speed of the projectile. I don't know. But it's actually useful to have that reference being passed. Because you can just call ranged attack and not care that it returns a game object, and it will work fine. All right, so we're going to save that. Kind of a big set of things we added there. Let's put a comment here. End ranged attack. Also, I totally just needed to remember that I need to also set the is attacking variable during these. It's likely that we're going to set it elsewhere, but we might as well set it here too. So if we did a point blank AoE, we should set is attacking to true. And if we did a ranged attack, we're going to set is attacking to true as well. probably also might be worth our while to also end is not stunned. Otherwise, you shouldn't really be attacking. So it'll spawn the projectile, and then we'll only say it's truly attacking if that was the case. So we'll bump that in there too. Which is going to be true up here as well. We should probably only do our search for if we are not stunned. So if not is stunned. So adding that around this so that it'll only execute the point blank attack if it is not stunned. So save those. And we did similar here. It's just I kind of attached that to there. So those methods are finished. So if you need to capture this, just pause the video. And if you need to capture this one, pause the video. So I do need a few things to bump me out of the attack state, otherwise I could get stuck in it. So let's make a, I feel like this one might need to be public due to the fact that the animator might be calling it. So public void end attack. We'll set is attacking to false. Another thing to consider, going into that like update block here in update behaviors, I kind of feel like in this case here, if I was decrementing my attack cooldown ticker, we should also, if attack cooldown ticker is less than or equal to 0, we should say is attacking is false, so that also will kick us out of the attack state. Just in case the animation doesn't pull us out, we can guarantee that we're going to leave an attacking state when this attack ticker is down. So that looks good. Let's update draw gizmos to include the melee attack radius now. And we'll draw this in red. Gizmo.color equals color.red. Gizmos.draw wire sphere. You know what? I'm just gonna copy this. And then it's, instead of range attack range, it'll be melee attack radius. Alright, so saving that. I'm going to minimize draw gizmos now because we're pretty much done with actually all the gizmos that it needs for debugging sake. Lots of debugging tools, which is really great for us as a developer to look at. And so with attacking, let's turn that into a region as well. Region attacking. And we'll do end region. So my attacks and all that is now encased in a region as well. Further helping me organize my script for the enemy. This script is actually very large. I mean, we've spent like 4 very long videos doing attacks for our enemies. Alright, have that set up, getting closer to being done. Now we need to jump over to the orange blob and actually get it to, commit to doing its attack. So after it does its update, it should start beginning to check for its attack logic. So it wants to do a melee attack. So if target is not equal to null and it is not stunned and it is not currently also attacking and its attack cooldown ticker is less than or equal to 0, then it will begin its attack against the player. But as I was typing this attacking variable, I did realize over an enemy, inside of the getting hit method, we should also bump it out of attacking. We should say is attacking is false, so that when the monster gets hit, its able to resume attacking at some point. So I added that line here right after is stunned is true. Otherwise, the monster could theoretically get stuck in its attacking forever, because if it started its attack sequence and you hit it, it may never exit that state because the animation got canceled. So, melee attack. Now we're going to figure out the distance to the player. So we're going to check the distance to the player. This one happens to be work a little bit easier if we do this as a vector 3. So this is called collider offset, and that I'm going to actually be getting the target's collider's offset. Because I know that the player might, its collider is a little bit on a lower Y position than the center, and we want to kind of change we want to account for that distance. And we could even do the same for, even though I know the blob offset's the same, but we could still do the same for the blob. We can get its offset. So we do a vector 2 distance of the target dot position plus the target offset, comma, the current enemy's transform dot position plus the enemy's offset. And that's just in case the colliders are in different locations, so that we're basically calculating the distance from the center of the player collider to the center of the monster collider. Because that's really what matters, not the center of the actual sprite, but the center of the physics center of the object. So if the target is within range, we're going to start a melee attack. So if distance is less than or equal to melee attack radius, and notice that we're able to pull those variables from the parent class. And so we're going to have the actual animation called the attack method, and also the animation will call the end attack method to exit is attacking. So we're just going to say if animator is not equal to null, which it's guaranteed to exist, but you know, we'll do animator dot set trigger, and that trigger is attack, and we're going to say is attacking is true, because the monster just launched and attack. We don't have a ranged attack for the blob. And so the blob, if it is attacking, I'm going to change its move modifier. I'm going to say move modifier times equals 0.5. Let's go 0.5. So it slows down when it's attacking. Gives the player a chance to step away from it, just to make sure the player is paying attention enough to avoid. Now, the blob inside of this attack method, we do need to define what is a blob's attack. And this is triggered by the animation, and the blob uses a point-blank AoE attack, and so we're just going to call that, and that's already defined inside of enemy. So this should work. We do need to set up the animator and make sure that the blob is good to go, but we're almost done with getting the blob to attack the player. So if you need to grab this, make sure you pause the video. But minimize. Let it compile all that hard work we just did. And I'm going to open up the blob prefab now. Let's go check its animation, its attack animation, to see do I have those triggers yet. And I don't. So I need to go add those animation events. So the blob animation, it's got like its teeth get red, and then it chomps down here at tick number 9. So that's actually where I want the attack to occur. So I'm going to right click here and do an add animation event. And we're going to put the attack event there. And then we just need to decide when should the blob be done with its attack. And so we're just going to take a look at its animation and decide that maybe right here we will send it the end animation attack. So it'll exit the state here after like it gnashed its teeth for a bit. So that looks good. We added those 2 events. We added the attack and also importantly end attack. But keep in mind the monster is still going to have like a half-second delay, so it will exit the attack state. So it'll be able to move at full speed again, but it won't be able to attack you yet. Okay, we're good with the blob. We can back out of that, save our hard work, and you can see that it's got its melee attack radius shown here. And let's go try our luck against this monster. It is currently not biting me. Alright, so let's take a look at why it could be doing that. Oh, this. Oops. And is not stunned. Kind of important there. So, takes a bite, it hits us, and we get knocked back. We're stunned while it does that. And so you can see, like, when it starts biting, it's going to slow down because it enters that is attack state. Then it speeds back up once it's done. And it actually will be able to bite you from any direction because we're going off of the colliders. And so if I'm even somewhat in that radius when it finishes with its teeth, it's going to hit me. And so now we've got the dilemma of getting surrounded by slimes is pretty much guaranteed death at that point. So it takes them from being a joke of an enemy to actually being pretty deadly. If you can only attack in one direction and these slimes have cornered you, you're a goner. You're just gonna get stun locked to death. Perhaps that is a little too mean, but now you can adjust the numbers to make it balanced to what you want. Or just, you know, tell the player to get good. Don't get surrounded by slimes. So that's going to wrap up the attack video. And I hope you enjoy having monsters that attack. The next video, we're going to speed things up a little bit. I'm going to provide an import library for a skeleton. And so we're really just going to set up the AI behavior for the skeleton, which should be pretty quick. We have to make the prefab for the ranged attack, and we're just going to, I already have the animation set up, and we're just going to load that in. So that'll be kind of cool. All right, well, thank you for watching, and enjoy fighting hordes of slimes.